So now we're going to talk about combinations, and we're going to start by doing a quick review. Here we have an example where we have a lock, and the lock has three different numbers that open it, that come together to open it. So for example, maybe the lock combination is 1, 2, 3, or maybe it's 3, 2, 1, or maybe it's 1, 3, 2. So all of these are different possible combinations for this particular lock to open it up. Now I don't want to confuse the word combinations here with the concept of combinations. It can be a little confusing, but I'm not really talking about this new topic yet. This is just a review. So because the numbers 1, 2, and 3 can be chosen to unlock this lock, and it does matter what order they're in, we're going to be using a permutation to figure out how many possible combinations. I know that's kind of confusing because combinations actually mean something else in probability, but how many ways we could put these numbers together, let's say it that way, to create a way to unlock this lock. Okay, so first of all, we need to think about how many events there are. So the events would be the number of numbers in your combination. So how many events are there? 3 numbers, so there's 3 events. And what's the total number of outcomes? The total number of outcomes would be the number of numbers you have to choose from. How many do we have to choose from? We have 40. Remember that 0 would be your first number, 1 would be your second number, so 39 is actually the 40th number. So there's 40 possible outcomes. So when I choose my first number, there's 40 outcomes to choose from, right? So let's think about it for each time we choose. So when we choose the first number, there's 40 numbers to choose from. What about the second time? We still have 40 numbers to choose from, right? What about the third number? We still have 40 numbers to choose from. So what does the fundamental counting principle tell us that we can do when we have multiple events and we're combining them together to find the total number of outcomes? What operation? We can multiply. So we're going to take 40 times 40 times 40, and that will give us the total number of possible outcomes. So figure that out. What does that equal? You can use a calculator. 64,000 possible outcomes or combinations for the lock. Now, what we used, the technique we use is called permutations. And we have done that before. This is really just 40p3. Does everybody remember that? So now let's move on and talk about actual combinations, at least what that term means in probability. So we're not talking about that here, different word there, different meaning for that same word. So are where the order does not matter. So it's different than a permutation in that with permutations the order mattered. So if my combination is 1, 2, 3, but 3, 2, 1 is a different combination, then the order does matter. So, but when the order doesn't matter, let's say outcomes are 1, 2, and 3, and those same outcomes 3, 2, 1 or 1, 3, 2, let's say that it didn't matter what order we got them in, that a 1, a 2, and a 3 was the same as a 3 and a 2 and a 1 and a 1 and a 3 and a 2, which would depend on your question. We wouldn't count these as part of our outcomes, right? So which one do you think is going to have more outcomes, a permutation or a combination? A permutation has more outcomes because you'd have to count this, this, and this. All right, so let's look at some examples so this will make sense to you. Here's the notation. It looks a lot like permutation. Same idea, but it's actually equal to all of this. So when you're solving a combination, you do the permutation, you calculate the permutation, and you divide it by the factorial in the denominator. In this example, we have a coupon for Papa John's to get a pizza with 4 toppings, and there's 8 toppings to choose from. So let's just go ahead and put in our information in the place of the notation. So there are 8 total toppings to choose from, and we're going to choose 4. So we get 8C4. just like with permutations, only the math is going to be a little bit different. So when we put in 8p4, we're going to calculate the numerator as we would permutation, 8 times 7 times 6 times 5, and in the denominator we're going to divide by 4 factorial, and that gives us 70. But let's think about if this makes sense or not. Are our toppings going to be in any particular order? So we have 4 toppings to choose from. Let's say we get pepperoni, cheese, ham, and onions. Does it matter if I put those in this order? Are those 2 different choices? No, we don't want to list this every possible way in every possible order, so the order doesn't matter, therefore this is a combination. Let's look at another example. 5 students would like to be a part of a group or committee that will make decisions about the middle school schedule. Only 3 can be a part of the group. The interested students are Alex, Buzzy, Shreyas, Taniqua, and Mallory. So what's the total number of students that are interested here? We have 1, 2, 3, 4, 5. But how many can be in the group? Only 3, right? So go ahead and write the notation. This is the basic notation. Now I'd like you to write all the possible combinations of students that could serve on the committee. Here I've written out the 5 initials, and then I wrote everything that could go with A and everything that could go with B, and then I think I had STM left over. So does it matter what order these are in? So if I have ABS, would I also write SBA? No, because we're talking about choosing students. We're not talking about them sitting in a first place, second place, third place. So SBA would not help me out at all. So once I write ABS, I don't need SBA or SAB or anything like that. So it's actually easier to write out combinations and permutations because there's a lot less. So now let's calculate and see if we have the correct number of outcomes listed. So we're going to put 5p3 over 3p3, calculate the permutation in the numerator, and notice I'm doing cross canceling here. You can use a calculator or cross cancel. I just like to play with the math. And I get 10. So I'm going to come back up here and make sure I have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do. Now complete this problem. You should have 56 ways to choose 3 puppies. Try this next problem. You should get 20 playlists. Let's skip to the last slide. The last slide is really important because you can master the math pretty easily, but thinking higher level in terms of what is a combination, what is a permutation, what does that mean, is really, really important. So we're going to take a minute to make sure we can recognize a combination versus a permutation. And these are some basic examples. So if you were to choose 6 cards out of 20, would that be a combination or a permutation? If you said a combination, you are correct. And here's the notation that you would use. Let's look at the next example. All possible lock combinations with a number made out of 4 digits chosen from the numbers 1 through 9, none repeating. So in this case, the combinations cannot repeat. You can't repeat the digits. What do you think? It's permutation, isn't it? Because order matters since you cannot repeat any of the digits. Let's look at the next example. 6 people remaining out of 18 in a game of musical chairs. What do you think? It's a combination, right? Next example, choosing 5 different flowers out of 12. Does the order matter when you choose your flowers? Nope, not a bit, so that's a combination. Next, first, second, and third place at the science fair. Oop, and I gave it away. That's a permutation. So anytime you have a first, second, or third place, that's going to be a permutation because order matters. If I'm talking about 3 people, let's say that's their initials, I have to think about it as first place, second place, third place. So this would be a different answer. First place, second place, third place. This would be a different answer. I'd have to take all these into consideration. So that's a permutation. Finish the rest of the problems as practice.